Welcome to this explainer. I want you to travel back with me for a moment to the year 1800. Just look around. What you'll find is a world held completely hostage by its own physical limitations.
Think about it. There are no cars, no airplanes slicing through the clouds, absolutely no electricity sparking to life in the dark. A journey of just 100 miles, that takes days of bone-crushing, exhausting travel. And moving heavy cargo across land? It's practically impossible.
See, the entire world was held captive by one incredibly fragile reality: muscle. Everything depended on the sweat of people or animals. That is, until a strange, cold machine appeared. A beast of iron that drank water, ate raw coal, and breathed thick black smoke into the sky.
And this brings us to a terrifying central mystery. How did something as simple as boiling water become a force strong enough to pull immense trains weighing hundreds of tons? Like, how on earth did a mere pot of water overpower 1,000 horses? Today, we're going to tear open the iron heart of the steam engine to uncover its secret.
Part 1. A world built on muscle. Let's look at life before the steam engine.
Deep underground, coal mines were constantly flooding, right? This forced workers into endless, brutal hours of pumping water by hand just to survive. Humanity was desperate for a new source of power, and that desperation, it triggered a massive realization about a forgotten force of nature. Water doesn't just boil, it pushes.
But what exactly happens when you trap boiling water inside a cold metal cage? What is this invisible force of steam, and how does it possess so much violent, dormant power?
Part 2. The force of boiling water. Let's do a quick thought experiment.
Imagine a sealed iron vault sitting right over a roaring fire. As extreme heat transfers through the metal, the liquid inside violently shifts its state. It becomes highly energetic steam. And get this, it expands to take up exactly 1,700 times more space than liquid water. Picture that massive expansion happening in just a fraction of a second.
Now, inside a sealed container, that expanding steam has absolutely nowhere to go, so pressure builds. It's like trapping thousands of invisible, coiled springs inside a metal box. The escalating pressure creates an unstoppable upward force, driving a solid metal piston with tremendous raw power. That single upward thrust, that was the spark of modern engineering.
So we have upward thrust. We have this phenomenal power. But how do you tame a beast like this? How do you take raw, explosive, chaotic pressure and forge it into controlled, precise engineering that can actually do work for us?
Part 3. Heart of the Iron Beast. Let's look inside the machine.
It all starts at the bottom, where a roaring furnace heats a massive iron boiler until the steam screams to escape. Clever valves guide this high-pressure gas directly into a cylinder. It rushes in, shoving a metal piston forward. Instantly, another valve opens, exhaling the used steam while fresh steam blasts in to push it back. Forward, backward, a relentless mechanical heartbeat of reciprocating motion.
Now, a piston thrusting back and forth is an incredible feat on its own. But there's a catch, right? Trains don't shift back and forth in straight lines. They roll. So how do we translate this violent linear pulse into a continuous, smooth rotation?
Part 4. Unleashing the Iron Horse, achieving that continuous spin.
The solution was actually quite simple, but entirely genius: the connecting rod. By linking the moving piston directly to a giant wheel, the sequence becomes a true mechanical heartbeat. Steam pushes, the valve opens, pressure releases, the wheel turns. A violent pulse perfectly transformed into an endless spin, firing dozens of times a minute. With this relentless cycle, the machine gained terrifying momentum. A single steam locomotive could now drag hundreds of tons across continents. Think about that. What once required thousands of exhausting workers could now be done by one tireless machine that never slept. It rightfully earned its legendary title, the Iron Horse.
But, as we know, every massive leap forward casts a dark shadow. Tampering with this much raw, volatile, elemental power came with a horrifying cost. What happens when the beast actually loses control?
Part 5. The price of raw power. These were incredibly dangerous engines.
You see, these early machines were volatile beasts. They devoured mountains of coal, choked the sky with black smoke, and honestly, they were astonishingly inefficient, wasting over 90% of their energy as raw heat. But far worse was the danger. If that immense boiler pressure climbed just a bit too high, the massive iron structure could catastrophically detonate in seconds.
literally vaporizing factories and trains. It was this looming threat of absolute destruction that forced engineers to constantly iterate. They relentlessly redesigned valves and reinforced steel, creating engines that were safer, stronger, and far more efficient. In a weird way, every catastrophic explosion brought the world one crucial step closer to modern technology.
Fast forward to today, and steam engines are obviously no longer the kings of transportation. We glide around on sleek electric and heavy diesel motors, which raises a fascinating mystery. Did the steam engine ever truly die, or did the Iron Beast just hide in plain sight?
Part 6. The engine that never died. Let's look at its quiet legacy.
The truth is, the elemental concept of using intense heat to create pressure didn't die at all. It quietly runs our modern world. Without steam, we'd have no mass production, no sprawling modern cities, no industrial revolution. But the ultimate secret is this: that exact same principle of boiling water still spins the massive turbines in modern power plants. It generates the electricity that lights up our entire globe today.
So, the next time you see a quiet, rusting steam locomotive resting in a museum, just remember, you aren't looking at some outdated relic. You are looking at the epic invention that broke humanity's physical chains. Boiling water literally moved the world, leaving us to wonder, what invisible force will we discover next to move our future?